Okay, so I wanted to explain about finding how many pi systems there are. So sometimes it's pretty straightforward. We have a system like this. So here it's very obvious that we have sp2 hybridized carbons here. Now here we have a methyl carbon. And then of course here we have a methylene carbon, which is going to be sp3 hybridized. So here we have a pi system with two pi electrons in it. All right. And then here we have another pi system. Now we have here this positively charged carbon atom. So this is going to be an sp2 hybridized carbon. And then of course both of these are sp2 hybridized. And so when we want to circle our pi system here, we're going to include that sp2 hybridized carbon. Now here again, we have an sp3 hybridized carbon, so we will not include that as part of a pi system. So here we have a second pi system. And this one also has two pi electrons. So if we were discussing this particular molecule, we would say that there are two pi systems. And both of these have two pi electrons each. Okay, now if we move into the next example, here we have a conjugated system with alternating double and single bonds. And then we have BH2. So BH2 is, of course, a BH2 group here. This boron is going to be sp2 hybridized because it's only bonded to three things. And we don't have a lone pair here. And even if we did have a lone pair here, honestly, if it were a nitrogen or something like that, that would be part of the pi system because we would be able to draw lone pairs. We would be able to draw a resonance structure that would include it. So here, this entire thing is one pi system because we have an entire network of sp2 hybridized atoms. And so that's going to effectively have, you know, this unhybridized set of p orbitals that are going to be involved in bonding in the pi system. Okay, so those 4 pi electrons will be spread out over that pi system. Now when we get, this is, by the way, this is question 14.3 from the Carty book. When we get to question answer C, rather, question C, here we have a carbon atom here that is sp3 hybridized. So that's going to be an insulator. And then this carbon atom has a positive charge. So that's going to be sp2 hybridized. And then there's a pi bond out here. Now, so this will be one pi system with 2 pi electrons. Over here, it's a little more complicated because we have sp2 hybridized atoms here, here, and here. But then these two are going to be sp hybridized, and they're triple bonded, which means that we're going to have one pi bond, and that triple bond is going to be sort of up and down. And then the other pi bond would be coming in and out of the plane. So that's going to be perpendicular to the other pi bond. So since they're perpendicular, they don't overlap in space at all, and so they can't interact at all. So whenever you have a triple bond, that's going to be 2 separate pi systems. But since we do have this network of sp2, sp, sp, sp2, and sp2 hybridized atoms, you'll have one pi system with 4 pi electrons, because we'll have the pi electrons from one of the double bonds, and then 2 pi electrons from one of the pi bonds in the triple bond. And then we'll have a third pi system, which will be the other pi bond of the triple bond. So that'll have 2 pi electrons in it. So we end up here with a total of 3 pi systems. One has 2 pi electrons. A second one has 4 pi electrons. And then the third one has 2 pi electrons. All right, so then the last one you asked about was 14.1. This is going to have a similar type of issue where, since you have this cumulated pi system, one of those pi bonds is going to be in the same setup, and then the other one will not be. Let me make sure I've got the structure correct. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 10 carbon atoms. And then this carbon here is going to be sp3 hybridized. So that means you'll have a pi system over here with 4 pi electrons, again, because we have a triple bond. So 2 of those pi electrons will be in the same plane as this double bond here. And then you'll have another one with 2 pi electrons, which will be your other pi bond in your triple bond. Then here with this carbon, because it's sp hybridized, one of the pi bonds it's involved in will be using one of the unhybridized p orbitals, and then the other one will have to be coming in and out of the plane. And so what that means is that you've got 2 separate pi systems here. So here, this will be one pi system with 2 pi electrons. And then here, you'll have another one where they can line up. So this would be another one with 4 pi electrons. Okay, so this particular molecule would have 1, 2, 3, 4 pi systems. You have one with 2 pi electrons, a second one with 4 pi electrons, a third one with 4 pi electrons, and then a fourth one with 2 pi electrons. And just a note, hopefully there were some examples like this, but let's just say we had a system like this. So normally looking at this, you might think, oh, well, you know, that's a sp3 hybridized nitrogen. But if I look at this harder, I see that I can, in fact, do the allylic anion pattern for resonance. So when I do that, what that means is that really this nitrogen atom is going to be sp2 hybridized. And I can draw another resonance structure here. So you end up with a total of 3 resonance structures. And the resonance hybrid for that would look like this. The partial positive on this nitrogen and partial, sorry, let me fix my resonance structures here. A partial negative on that carbon atom and a partial negative on that carbon atom. And so with this, what we end up with is a 1 pi system with 6 pi electrons for this.